So since you've, which number is this again?
We are
12.
on number
12. So since we've doubled the mass, its inertia, its stubbornness is doubled too. Stubbornness. You've doubled the stubbornness. So it's half the acceleration. Alright. Now we are on 13. Sports car. Actually, we don't need to do that. That's a straight up equation. You guys have done fine with those. Tow truck experts exerts a force of 200 newtons. We don't need that either. That's straight up equation. Let's take a look at number 15. 15. 10 kilogram brick and a 1 kilogram book. They're dropped in a vacuum. So what does weight depend on? Gravity and mass. Mass times gravity. So, well, gravity is the same for both of these, right? So the only thing that weight depends on is, it depends on gravity, but since it's the same, we can kind of count those out in our comparison. So this has 10 times the mass, so it has 10 times the weight too. And what is weight?
Weight is force.
Force of gravity. We are going to remember that yet. Force of gravity. 16. All right. 16. Did everybody get 16?
Yep.
Do you understand?
No, I did not get 16.
Okay. So we have this box, right? What all do we know about this? Coleman, go ahead and read what we know at least.
Should have been B.
It should have been B.
Okay.
It had 25
Well,
newtons.
I thought it would have been B, but then it was like if I wanted to go actually start going, would have had to overcome it and then have a little bit more to keep it going.
Right. But
That's how I always
to keep something going, that's because you're only applying your experience. Because yes, you are exerting 25 newtons of force, but there's 25 newtons of force coming right back at you.
Exactly. So wouldn't you have to have more than 25? I might just be stupid.
To keep a constant velocity. Remember, this has a constant velocity.
I know. Isn't it going to equal it out? 25 this way and 25 this way equals 0.
When you think about
Yep.
it, it seems like it would just keep the object.
Mm-hmm.
So
Now, okay, but according to Newton's first law, that's probably why they talk about Newton's first law first. Objects, if they're in motion, what do they tend to do?
Stay in motion.
Stay in motion. So the only way that it's not going to stay in motion is what?
There's 25 pushing that way.
If a force is pushing it back. But in this case, we push with 25 newtons to keep it moving.
But
If you're
So-
pushing with 25 newtons and something else is pushing back with 25 newtons, that doesn't explain how it's moving.
Uh-huh.
I feel like
It can,
just you have to push with more
look,
than
I'm
25
going to
newtons
push
to
with
get-
5.
right.
I'm going to push with X amount of newtons this way and X amount of newtons this way. This thing is not going either way right now because I'm pushing and I'm equaling them out.
Mhm.
I got 25 here and 25 here. I'm not going
Right.
anywhere.
But if an object is already in motion, it tends to do what? Keep moving.
So
Okay.
whenever
So-
you have a question like this, just assume that it's already been in motion.
Yeah.
Well, I did it.
Yeah.
We've established that.
We both did with our video.
Established that.
I
Yeah.
forgot that.
We talked about, yeah. So if it's in motion, that means it has started in motion. It's not stationary. If it says constant velocity, assume it's in motion. Okay. So it's in constant velocity, it's moving at a constant rate. So in order to keep it moving at a constant velocity, if it's constant velocity, what does that say about its acceleration, Ross? Acceleration, not quite.
It's zero.
If the velocity is constant, what is acceleration?
Change of velocity.
It's change in velocity. If the velocity is constant, is there change in velocity?
So,
No. So if velocity is constant, acceleration is nothing. So if acceleration is nothing, what must be true about the amount of force? The net force.
Is zero.
Yep. Net force is
Okay,
nothing.
just go to 17.
Wow, wow, wow.
Remember when Michelle, remember when
This is-
Michelle always fell asleep in chemistry? And
It's
like
so
when you would call
frustrating.
her, you'd like, she'd like wake up and be like, in Jesus' name, amen.
Science.
I don't remember that.
That's what she did.
I try to block it out of my
Yeah,
memory,
she was
evidently.
like-
Okay.
That's how she would play it off, like she was
Hey,
praying.
shh. We're recording,
Oh,
okay?
oops. My bad. Sorry, recording. Okay.
17, that was straight out of your notes. The very last slide, I
Yeah,
think.
C.
It is, with the chute open, is 15. Without the chute, it's 150. With the chute open, it's 15.
Where did we find this?
The very last slide of your notes.
Oh, you tricked us.
I didn't trick you. They were both there on the same page. Oh.
Just kidding.
As a care package falls from a high-flying stationary helicopter, its velocity increases and its accelerate. Oh, this is the one that I wrote in a letter, right?
Yeah.
So that is because I didn't count it off, because I'm a nice guy. Also because we have talked about acceleration being constant. Like in previous chapters, we've talked about acceleration being constant. But in this case, we're talking about air resistance. Okay, when we're talking in the context of air resistance, we want to include, like, okay, I should preface that with, before, when we were doing all of our other stuff, we were assuming that there was no air resistance, okay?
How were we supposed to know is there air resistance? Did the high flying part? do
And that's why I didn't count it wrong, because I felt like, it wasn't very clear. You will, like, you should be able to describe that as something falls in real life, the acceleration is going to decrease.
Can you
because-
make it obvious that air resistance is a factor?
Yes.
Good.
If it's not obvious, then I won't.
Bold.
Then I won't. Well,
Air resistance!
no. 36 font.
Yes.
Here's the example.
There's an
You guys?
entire page that
Didn't
says
you
air-
just say if velocity increases, acceleration decreases? Didn't you just-
If velocity is constant, acceleration is
Oh,
nothing.
right. So this is velocity increase.
Velocity is increasing. Yes, but it's a little bit different. And this is how we'll get there. Do you remember our picture? Our diagrams of the person diving?
Oh.
This is good.
Do you remember our before and after pictures? Guys, stop doing math.
Sorry.
Do you remember our before and after pictures? And something was falling. Before, here's gravity. What's true about the force of gravity on the guy? Before and after?
It's the same.
It's the same. But then you have air resistance. Before, what's true about the air resistance?
It's small, so it's not very much.
You're not hitting very many molecules, so it's pretty small. Later on, as velocity increases, you hit more molecules, right? Just like in your car, you feel the wind a lot more when you're driving fast. Yes? So as velocity increases, what happens to air resistance?
Air resistance
Increases. So your net force, what's true about your net force here?
It's less.
Here? If you put gravity and air resistance together, it's going to be quite a bit. And then here, the second time around, because there's more air resistance, we have less net force. But is there a net force the second time around?
No, seeing as how they're equal. No, is it a 0?
Yes.
Yes, there is a net force. Is it as much as before?
No.
No. So even though you have less net force, you still have a net force. So what's true about, do you have acceleration?
Yeah.
Yes, it's just less. But you still have some. So it is still increasing its speed. Okay. The reason a tennis ball and solid steel ball will accelerate at the same rate in the absence of air resistance is that
See.
the ball with the larger force also has more inertia. Do you guys understand why that is? I know some of you do.
We just drew it out.
When? Oh, kind of with this one.
Is the test gonna look a lot like this review?
Yeah,
Like, can we study off of this? and
Quite a
be
bit.
good?
it'll look a lot like it.
We did. We drew it. Right there.
So that's where it's from. If it has more mass, then that means it has more force acting on it. But if it has more force, it's because it has more mass, and it's more stubborn. So they cancel out. That one was for 19. So it's kind of the same reason as for number 11. You could even say same reasoning as 11. Something like that. Okay. Shooby-dooby-dooby. Acceleration inversely proportional. False. What would you do to make it right?
Yes, directly.
It's directly proportional. So if you double force, you double the acceleration. That is if mass is the same. Excluding, some people miss this one. Excluding the force due to air pressure, there's only one force acting on the book, lying on a tabletop. Why is that false?
So there's the force that's-
There's gravity.
There's gravity pushing down,
No, the table's pushing.
but the table's also pushing up. Fluid can be either a liquid or a gas. Yeah, that was just in our notes when we were talking about friction. Why is the teacher in figure 5.8 in the book unharmed? Yeah, first of all, why is it unharmed? Caleb?
Because the amount of nails per there's a lot of nails per square inch, so the pressure is evenly distributed.
Yeah. So there's more surface area for the force to be spread out on, so it doesn't hurt it. Yep. Is it important that cement block have a large mass? Explain.
Yeah.
Yes, why?
Because then the bigger the area, the more nails there are, and the less force will be.
Yeah, well, we're talking about the cement block now, though.
When you have more mass, you have less acceleration because you have to get through all the mass, so there's less damage to the skin.
Yep. More mass means less acceleration of the nails into the skin. That sounds like a good thing to have. Less acceleration into the skin. All right, so number 24, you can answer it a couple different ways. One, the mathematical way. So
24?
20 kilograms, yep. So you have 20 kilogram object, acceleration of 2.0 meters per second squared. This other object is 30 with the same force. Hey, 30 kilograms, same force. What's one way you could do it?
acceleration equals force over mass.
I like that. You could just do what you know. Acceleration equals force divided by mass over here. So, or actually, you're looking for the force here. So you could also do this equation. Force equals mass times acceleration. So 20 times 2 equals 40. Stop it. It's wigging out. 40 newtons. So 40 newtons are, we said that it's the same amount of force. So 40 newtons are applied here. Come on. 40 newtons equals, well, we know the mass here, right?
Took off half a point because it didn't show my work.
Mm-hmm.
Why?
Because I want to see how you got it.
But I did it on the calculator.
So show what you put into the calculator. So 40 newtons equals 30 kilograms times the acceleration. We don't know that yet, so we can do 40 divided by 30 newtons. So 40 divided by 30 is 4/3 of a meter per second squared, or 1.3 meters per second squared. I would accept either one. Another way you could think about it is the mass is 4/3. Wait, whoops.
I feel like I'm missing.
The mass is 3/2 of before. So what's true about the acceleration? Mass and acceleration are
Acceleration is 2.
inversely proportional, yeah. So if mass is 3/2, that means acceleration is 2/3 from before.
Oh, yeah, because it's just like that.
Yep, because they flip-flop. So 2/3 of 40, or wait, 2/3 of 2 equals 1.3. So I don't care how you do it, both are great. Net force, 25. We're not going to do too much of that, but what I wanted you to do is you figure out the acceleration thing. So force divided by mass equals 1/4. Then you do distance equals 1/2 AT squared. That wasn't worth much, so I didn't count off much. Bronco. This one, you were told that he's 80 kilograms. Is that force?
Yes.
No,
No, mass.
it's mass.
Oh.
So it tells you there's 200 newtons of air resistance. This would help a lot to draw out so you can see it. 200 newtons of air resistance. But we're told a mass also. So how do we, and we're looking for the acceleration. So acceleration equals net force over mass. Do we know the mass? Sure we do. It's 80. Do we know the net force? No, we don't. This is the mass. So we can figure that out though. Weight equals mass times gravity. So 80 times, are you guys who got this wrong? Are you writing this down? Okay. 80 times 9.8. So that's how you can find the mass, the force downward. What was that? What was 80 times 9.8?
Very small this way.
700, what's that? 784 newtons down. So 784 newtons down plus 200 up equals 584 down. And that's what goes there. 584 divided by 80 equals 7.3. Yes.
Yes.
Meters per second squared. Okay. Set 27 is fine. 28. All you have to do is take the newtons, 10,000 newtons, times the percentage. So 10,000 newtons times 0.8 equals 8,000. And 29, if you have mass, it's in kilograms. So 5,000 kilograms times the gravity. So then you multiply that. See you later.
Okay, so be really careful and check, make sure it's make sure you have weight, not mass.
Yeah. If it says weight, that's force. If it says mass, that's mass. And you have to multiply by gravity to get the force. Yep.
Alright, see you later.
See ya. 0.8
Got it.
equals your answer.